Alright guys, this is the second video for 7.4 and this one won't be as long as the first one. So now we're going to talk about rectangles and the properties of rectangles. Okay, so we have this rectangle diagonals theorem. So a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so we automatically know that the diagonals bisect each other. And now we know they're congruent. They bisect each other because a rectangle is a parallelogram. Properties of parallelogram, they bisect each other. But now they're congruent. So because they bisect each other and they're congruent, now we'll call this M. Now this is the same as this, but it's also the same as this and also the same as this. So all four of these pieces are congruent in a rectangle. All right, so let's look at this example. It says in triangle QRST, QS is 5x minus 31 and RT is 2x plus 11. Okay, so because this theorem tells us that the diagonals are congruent, that means that QS and RT have to be congruent, so I could set these equals. So 5x minus 31 equals 2x plus 11. Minus 2x on both sides. I get 3x minus 31 equals 11 plus 31. I get 3x equals 42. Divide by 3, divide by 3. And I'm left with x equals 14. Okay, but it doesn't say solve for x. It says find the lengths of the diagonals. So I'm going to plug 14 in. So 2 times 14 plus 11, that's 28 plus 11, which is 39. That's RT. Now, if we did everything correct, QS should be the same thing. 5x minus 31. 5, my x is 14 minus 31. 5 times 14 is 70. 70 minus 31 is 39. So each of the diagonals are 39. All right, let's look at example 5 now. Okay, it says you're building a frame for a window. The window will be installed in the opening shown in the diagram. Okay, so part A, it says the opening must be a rectangle. Given the measurements in this diagram, can you assume that it is? Explain. So I want you to look at this, and you really have to look at it. And I need you to decide, do we know for sure whether or not this is a rectangle? All right, well, we do know that both pairs of opposite sides are congruent, which means that it's a parallelogram. But that's all we know, okay? We don't know that these are 90 degree, they look 90 degree angles, but we don't know that. So no, we only know it is a parallelogram. I'm going to put in parentheses, both pairs, opposite sides are congruent. All right, now let's look at B. It says you measure the diagonals of the opening. This diagonal is 54.8 inches. Okay? And then we measure this diagonal, and it is 55.3 inches. Now what can we tell is for sure true about this figure? Okay? We know it for sure is not a rectangle, because if it were, the diagonals would be congruent. All right, let's go ahead and look at example 6. Now there's several ways, countless number of ways you can do this. But the first thing you need to do is graph it, okay? Then I'm going to just find the slope of each line. So this is going up 1, 2, 3, 4, 5, 6, 7, 8 over 2. So my slope 8 over 2, which is the same thing as 4 over 1. Okay, and I'm going to do the same thing with AB. So I'm going up 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So my slope is 2 over 8, or 1/4. And then B to C, I'm going up 1, 2, 3, 4, 5, 6, 7, 8 over 2, which reduces to 4 over 1. And then I'm going up 1, 2, and over 1, 2, 3, 4, 5, 6, 7, 8. So slope is 2/8, or 1/4. So just by that, I can say it's a parallelogram because opposite sides are parallel. Okay. Remember, to be parallel, you have to have the same slope. Okay. Now I need to see if it's a square, a rhombus, or a rectangle. Okay. Well, now I can look at these slopes and ask myself, are these opposite reciprocals? Because if they are, it's a 90-degree angle. If it's not, then it's not a 90-degree angle. These are reciprocals, but not opposite reciprocals. Remember, opposite means one's positive and one's negative. So I can immediately rule out that it's not a rectangle or a square because sides are not perpendicular. I'm going to put not opposite reciprocals. Okay, now I need to check to see if it's a rhombus. Okay, well, there's a lot of things we can do. We can do the distance formula for all the sides to see if they're all the same. But I think the easiest is to see if these diagonals are perpendicular. Okay, so to see if the diagonals are perpendicular, I'm going to find the slope. So from A to C, I'm going down 1, 2, 3, 4, 5, 6. So down 6 over 1, 2, 3, 4, 5, 6. So I have a slope of -1 over 1. Okay, now I'm going to do the slope of this. So it's up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 10 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which reduces to 1 over 1. So we have a positive 1 over 1, negative 1 over 1. Those are opposite reciprocals, so these are perpendicular, and therefore this is a rhombus. So we have it's a rhombus, it's a parallelogram, and I could also put it's a quadrilateral. It says put all names, quadrilateral.